I got a couple of quadratic equations on here. Anybody got any questions about quadratics? Any questions whatsoever about quadratics? No questions about quadratics? We worked a couple of quadratics, didn't we? But which one? I know we worked some in the other, my other classes, but there was algebra class. Which ones have we worked in here? Anybody? Any particular ones that you think of? Did we do the one about the profit with the bicycles? No. What if you had the profit function that somebody came into your company and they wound up after looking at your company, and that's what they came up with your profit function. And profit functions are in the realm of quadratics. And how do you recognize that that's a quadratic to begin with? How do you know that that's a quadratic equation?
X squared.
It has what? The highest power is a 2. It's just, how do you know just by looking at that what it looks like? Do you know what that looks like immediately when you look up on the board and you see a quadratic equation? Now they may not always give it to you in this form, because this is what? This is the pure quadratic form. The general form, it's called. How do you know that that's, I mean, do you know, first of all, how would you know that could possibly be a profit function? First of all, you see the negative in front of the squared term?
Yep.
That automatically tells you that that function does this. Automatically. You remember that, right? If it's positive, it does what? It's a smiley face. Certainly, you would certainly hope that you would not have a profit function that had a plus. And it would look like this. Because nobody in their right mind would want to minimize their profits. What could you think about would be shaped like this, possibly?
A U? A U?
A what?
A U?
Losses.
A what now?
Loss.
A cost function. You'd like to minimize your costs, right? So if somebody came in and they built you a cost function, it would look like this. Just like the profit function is going to look like this. In this particular problem, what do you want to know most of all?
How much you're going to make.
Yeah, take a look. If that's bicycles, do you see why that, you know what this is, everybody? What do you think this is?
Overhead.
That's a fixed cost. Hell, you know it can't possibly be a plus 2,000. If that was a plus 2,000, I would sit and not build a single bicycle one and collect my $2,000 a day or a week or whatever. That's essentially what it's saying. But that says what? You make 0 bicycles and you owe somebody $2,000. So it'd have to be a negative number on the end to be a fixed cost. Certainly wouldn't be a plus. So what else would be something you'd want to know about this problem? The question was, The question was this: what is your profit? What is your profit if you make 110 bicycles? If you make and sell 110 bicycles, how much is your profit? So what are they asking you to do?
So when X is
Plug the dang 110 in for X. If X is the number of bicycles you make, and then you got what? 110 bicycles, you make it 110 bicycles. Somebody tell me, for goodness sakes, what in the world does that tell you? What does it tell you? Well, hell, let me give it to you. Very little. Very little. It tells you very little. First of all, the function looks like this. You know good and well that this is what? Minus 2,000. When X is 0, this is X. This is what? That's the profit. So when they say, how much profit are you making when you build 110 bicycles? Well, guess what? You don't have a clue where the 110 is located. Is 110 located there? Or is 110 located there? Do you see what I'm saying? And you won't know that. You won't know where the 110 is located until you do what?
solve it. Solve.
Till you do what?
Enter it in. Like substitute X for 110.
It won't tell you anything, will it? It will not tell. Hell, are you making enough bicycles? Does that tell you, are you making too many bicycles? Yes or no? You don't know. How are you going to know? Listen, everybody. You must find the vertex of this problem. If you found this vertex, whatever number is located there, that will tell you quickly where the 110 is located on the left or the right side. You understand that? You may be making too many bicycles. You may be losing money unless you know what this number is here. Is everybody with me or not? No? Half of you's not? Half of you's not listening, but that's okay. How do you find that number? How do you find that number? You all better know this.
2a over b squared.
I thought I heard somebody say it.
The 2a over b squared?
It's what? Almost. Close. No, backward. What?
2ac over
No.
B squared over 2a.
No, hell. No.
Negative b over 2a. Negative b over 2a.
There's a b in
Negative b over 2a.
Negative b over 2a. What does that give you?
That is using
What does that give you?
the y coordinate. No,
What does that give you?
Critical point.
The first number of the vertex. The first number of the vertex. Minus b. Where is minus b located up here? This thing is already in the perfect form, folks. The minus 0.5 is a. And guess what's the b? 120. So what is the first number of the vertex? Hurry. This is pretty tough. You have to take 120 and divide it by 1.
120.
Damn, that's hard. 120 divided by 1 is how much? 120. So guess what? This number is here, folks. So you know that the 110 is located where? There. It's telling you clearly that no, you're not making enough bicycles. So what is the maximum profit when you make 120 bicycles? You just plug the 120 back in what?
Equation.
Into your equation. Do that quickly. Take a calculator, plug the 120 into the equation. Does that make sense? Listen, that's as hard as quadratics get. What is the number? What is that point called? What is that point called?
Critical point.
The critical point. You know why it's called the critical point?
Because it's critical.
Perfect. Because it's critical. It's the most critical point on the picture. It's the most critical one. Now here's why you have to realize what you're doing. Y'all listen to me. How many of you in this room have ever had to factor a quadratic equation? Let me see a show of hands of everybody that's ever factored a quadratic equation. Right? Have you done so ever? I think so. Do you know why you did that? You're finding where the darn function crosses the x-axis. What will it mean in this problem? What is the meaning of factoring this problem in this problem?
The break even.
It's what?
The break even.
It is the break-even point. It is where you make $0. In other words, the profit is where? Wherever this value is and wherever this value is out here, it's going to be what?
In between those.
It's going to be the break-even point. In other words, you can make so many bicycles and you make $0 profit. You paid the $2,000 off. That's why you factor, folks. You wouldn't need to factor this problem if nobody wanted to know the break-even point. Most importantly, they would want to know what? How many darn bicycles must I make to make myself a profit? The maximum profit, not just any profit. Have we worked this problem in the class before? Have you worked another quadratic equation? Can you think up another quadratic equation? Anybody? Okay, suppose I told you this. You have a spot of ground that you have an apple orchard, okay? And you've had it for quite some time, and guess what? You had 25 trees planted. After all the years go by, you have recognized that the yield has always been 450 apples off of each tree. That's been your yield. You've been quite happy with that. We don't know how big a spot of ground you have, but what happens if the extension agent comes out to your place and says, you know what, we've got satellite pictures of your farm, and we don't think you're making the best use of it. According to our study that we've done, you don't have enough apple trees planted. Because would you not want to increase your yield? I mean, people do that, right? Don't they try to increase what they get off the farmlands? One absolute truth in this is what? You know what, folks? You got to realize this. 40 years ago, no, 50 years ago, 40% of Americans were farmers. You know what percent of Americans are farmers today? 2%. And we still grow what? Just as much food. Why and how? How did that happen? Because they have what? The technology is paid off. It's the technological world. When I grew up on the farm, it was a wonderful crop if we got a bale of cotton per acre. It was great. Now they get what? 4 or 5 bales per acre. And how they do that? I mean, I know a guy he grows about 3,000 acres of cotton alone. And when he harvests his cotton, guess what he has? He has a computer system on the harvesting machines. And it tells him exactly where per square foot, how much cotton is coming off of each per square foot of land via satellite. And it also tells him, hey, look, this spot didn't get too much. And they plot this thing out, and it tells him exactly, that satellite tells him exactly, there's not enough nitrogen in the soil in that spot. You need to do something to this soil on this side of the farm. And in specific blocked areas, it tells them exactly, you need lime in this section. So that's how it happens. So they have these methods and means of doing what? Of telling you, wow, you can increase your yield. And this guy has come to your house and he said to you, for every single tree you plant extra on your piece of property, the size of it that you have, you're only going to lose 10 apples per tree. You're only going to lose 10 apples per tree. Do you plant another tree? Do you plant another tree? Okay, all right, well, let's see. What do I do? I mean, folks, that's a yes or no answer. Some of you, okay, half of you not working on your math, so some of you's working on other stuff, so is it time to go? I may be going because I'm missing out on a dinner right now. So I came down here to teach something. So, but my question is, do you plant another tree?
Yes.
Yes, yes, yes. How do you know that?
Because you lost 10 apples of every tree.
How do you know that? How do you know you plant another tree? You did the arithmetic. You multiplied 26 times 440, and you recognize you got a bigger number than you got when you multiplied 25 times 450. Yes or no?
Yes.
Did you plant 2 more trees? All right, how many more trees do you plant? 25 million? I don't know. That makes sense? Let's plant 25 million trees out there. Well, they'd do that if they wasn't losing apples per tree, right? But what would they do? They'd plant 10 million trees on this piece of property. If they got 450 apples, then it wouldn't affect them. So they'd plant as many trees as you possibly could plant. That doesn't work that way. After a while, you start to lose apples, right? How do you know that for a fact? Well, because you've got to do what? You've got to build yourself an equation that fits this problem. You got 25 trees down, right?
Yes.
You got 25 trees down, right? So you're going to ask yourself, I'm going to plant that many more trees. I don't know exactly how many more, but I'm going to plant this many more trees. So that's what? I have now 450 apples per tree, but that means I've got to take away what? 10 times the number of trees that I plant. Look at the problem, you all. What does that problem look like? If it's what? It's a binomial times a binomial, so multiply it out now. Multiply. Well, okay, let's do something, she got something on here that's set out the distance for you. Okay, we need to work on that, shouldn't we? Yeah. Did everybody get your code to work? What's
They're
going
still
on?
sold out. They're still sold out.
Yeah,
It's what?
They're sold out in the store.
No, they called me this morning because they got more codes, but they ordered the wrong ones now, so I have to wait again.
I don't know if you can go to the actual website and buy it though, the Pearson.
They might have it at, the bookstore up the road.
No, they don't.
Nope.
Ordering codes for this course takes minutes. They're here via what?
Internet.
The computer. They just send it via computer.
Well, apparently.
No, they have a hard copy of it. They get the little cardboard thing, and that's what they're waiting on.
Wait, no, the what now?
The little cardboard piece of paper that's got the actual code inside of it.
They actually supposed to just send it via email.
You think so?
You should go talk to them.
He told me they would try to have it in by the time I was done with class. And I left the bookstore like 12:10.
Yeah. Hold on a second. Lindsay, where's Lindsay? Mario's not here. They sent him a code and it didn't work twice. So I didn't know if that happened to somebody
No,
else.
that's what they did to me.
It didn't work.
The second code that they sent, it had too few digits. They were ordering the wrong codes for the wrong program.
Wow.
I mean, we can go down there and buy it together if you want. You can.
Yeah, you know how long it took me to get my
Who
code? It took me
published
about
it?
30
Pearson?
seconds.
Yeah.
I just picked up the phone
You
and
better buy it from here.
dialed the number and told them to send it to me. And they sent it via email. Opened up my email seconds later and it was there. That's what they're supposed to do.
They're not smart.
Anyway, let's get away from this problem. Everybody do this problem. Multiply that out and see what you get.
What's it called now? Pearson. Pearson Education.
Take a piece of paper and pencil and multiply this out, everybody. You got it? You got it multiplied out? Anybody else have it? Anybody else have it?
This guy.
Oh, that's negative x squared plus 200. Plus 1,350.
Did you get that, I think?
Yeah.
Yeah.
Anybody not get this? Everybody get there when you multiply it out? Combine the like terms? What does this problem look like, everybody? What does this one look like? It looks like this. Right? How do we know that? Because it does what? It starts at this point right here. When you don't plant any extra trees at all, when X is 0. When X is 0, you're getting what? 11,250 apples. In this particular problem, how many of you are interested in knowing what to do to factor this to make it equal 0? Anybody?
No.
Absolutely not. Why would you want to know that? Why would you want to try to factor this to try to find out what makes this equal 0? That's not what I'm interested in. What am I interested in knowing? I'm wanting to know this value that's going to do what? Maximize my yield off my farm. How do you find that? How do you find that number? It is negative b divided by 2a. Do that now. Everybody. And what'd you get? 10. 10. You got 10. What does that tell you? Your maximum of 10 trees. You plant 11 and you're going to do what? You're going to start losing apples again. You plant 9 trees extra and you go what? You're going to lose apples. You're not going to make the maximum production or the maximum yield off of your spot of ground. And that makes, it's sensible, you all, because certainly you're not going to be able to plant an unlimited amount of trees on your farm in that spot, because you'll eventually have what? A whole bunch of bushes with no apples on them. Bunch of trees with 0 apples because the sun couldn't get to them and to make the apples. The nutrients, you couldn't keep it. Did everybody see this? Is that a reasonable problem or an application of quadratics? I would hope so. And no, I know you spend a lot of time, and you've spent a lot of time factoring quadratics, right? Factoring to try to find out what makes them equal to 0. Is that important to know here? No, because look, there's one of the spots right there, way back here. The other one is where? Way out here somewhere. I could care less about these two numbers. So there comes a time when you don't really need to factor and set it to equal 0. That's why it's called the critical point. Because you'd rather know the critical point, because that is the most important point on the entire graph. Does that make sense? They spend a tremendous amount of time having you do what? Factor quadratics. They spend a tremendous amount of time. Can I erase this away? This is all gone. This is just to sort of refresh your memory about quadratics. This is probably one of the more famous and more useful quadratic equations that you'll ever encounter. Anybody recognize that equation?
Yeah. Something falling. Something falling. Gravity.
Something what?
Something about gravity.
Something.
Something about gravity.
Something about gravity, like he said something. It's actually what? It's something what? It's when you throw something up in the air. When you throw something in the air, folks, that's how it behaves. Period. You don't have any control over that. There's only two things you have control over in that problem. And when you're looking at it on the board, it's the 96. That's the initial velocity. We just made that up, okay? The 20 on the end of it. You know what that represents? That means you're standing on a platform 20 feet off the ground when you throw it. And it has to be thrown straight up in the air. And when you throw something straight up, it's going to come straight back down. It is going to follow that particular what? Equation. You can't change that. You cannot control that. So, the only thing you can control is what? You could say, hey look, let's make the problem easy and stand on the ground and throw it from the ground. Pretend that wherever it leaves your arm or whatever it comes out of or whatever, the muzzle, that's ground level. Then this would come off to make this a lot easier problem. Okay? Second thing that's important that you better know and you better not forget, and that is this. That's the initial velocity. And the equation you're looking at on the board, that 96 is feet per second. The 96 is feet per second. How do I know that that's feet per second and not meters per second? How do I know that? Just by looking at the darned equation. Nobody even has to tell you that it's feet per second. Why is that? Because the equation is cut in stone and you have no control over it. It is minus 1/2 AT squared plus VIT. The height is equal to minus 1/2 AT squared plus V sub IT plus some constant C. That's cut in stone and you have no control over it. So the minus 16 in front of that problem tells me that 1/2 of gravity is 32 and height that's about 16. 32 feet per second is what it is in what? The English system. If that was meant to be 96 meters per second, it would be minus 4.9. You forget that, you're in trouble. Don't you ever forget that, because it's too important to forget it. Not just for this class, but for what? For the rest of your life. What questions could I ask you about this problem that you're looking at on the board? Somebody list some questions that I could ask you.
How long does it take? Like, how fast is it going at some certain height?
What?
Yeah, maximum height.
Yeah. How high is it going to go in the air? Whatever you throw. I don't care what it is you throw. A rock or a baseball or whatever. I'll throw a cow in the air. I don't care. You do what? Throw a bucket in the air. Provided you do what? You throw it straight up. This thing is going to do what? Its picture is going to look like what? Like this. Now, if you started out at 20 feet off the ground, it'll do what? It'll start to do this. It's the only difference, everybody. So you just have to assume that what? Let's just make this an easy problem by assuming that what? No matter where you're standing, that's ground level. So just take that off and make the problem a simple problem. The question would be what? How high is the rock going to go in the air? Go. Go. Quickly, find that. What'd you get? Huh? I don't know. No. No. working on something else. Look, okay. It's time to go. So, did anybody get this from work? You finish up with it? Everybody get it? Find the vertex. Find the vertex. How do you find the vertex? Say it. Minus b divided by 2a.
Oh, yeah.
Yeah, minus b divided by 2a. What's 96 divided by 32? 3. Guess what? 3 seconds, and it's at its what? Maximum height. And what is that? Put the 3 into the equation. And what'd you get back? What'd you get back? 144. So in 3 seconds time, it's what? It reached 144 feet. It will not go any higher than 144 feet. I don't care what you throw in the air. You throw it in the air at 96 feet per second, it is going to go 144 feet and come back down in 3 seconds. How long is it going to be in the air? A total of what?
3 seconds. Or 6 seconds.
6 seconds. 3 seconds up, 3 seconds down. How would you know that? Well, if you wanted to know that, you would say, okay, now is a good time to do what? Find out when it's on the ground, when the height is 0. You can factor this by doing this, right? Is that not a factorization of this? When t is equal to 0, it's on the ground. Gee, well, there it is, right? It's on the ground. Or when t is equal to what? 6. Look, it's on the ground. It's 6. So guess where it has to be at the maximum is at 3. That makes sense to everybody? How fast is it going to hit the ground? How fast is it going to hit the ground?
27 meters per second.
How much?
27 meters per second.
What'd you do go about changing my problem for me? So you went from what? From feet per second down to meters per second. How fast did it hit the ground?
Same speed it went up in there. Same speed that it went up in there.
96 feet a second?
Yes.
How do you know that?
32 times 3.
It's simple. That's how fast anything hits the ground.
Velocity equals
2 times gravity. And if you don't believe this, this is square root of 2 times 32 times what? Check the arithmetic to see what you get. Check it out.
Sweet.
Did you get that?
Yeah.
What, how did you get that? How did you get that? How did you just know that's what it has to be? No matter what you have, folks, I don't care what you hold or whatever it is, it's down. That doesn't make any difference what it is. This item has potential energy, right? And the potential energy, anybody remember how to get potential energy?
Negative mgh.
It's just mass times gravity times height, right? That's potential energy right there. That has potential energy because it has height. this also. Now, if you don't believe this part, then this also has something called what? Kinetic energy, and you know what it is? It's what? If you don't believe it has kinetic energy, just stand right here, and I'm going to stick your foot out, and I'm going to drop it on your foot. Any volunteers? So you don't want to feel the effects of that kinetic energy, so you have to agree it does what? It does have kinetic energy. Think about it, folks. Right now, suppose that is as high as this is ever going to go. Can you not say right now that its potential energy is maximum? Yes or no? Yes. Think about this. What is its kinetic energy right now at this very moment? Zero. Because it's not moving. So as I let it go and it starts down, guess what starts to decrease and then what starts to increase? The potential energy starts to go towards zero, and the kinetic energy goes what? Towards maximum. Am I making any sense what the hell soever? I know I'm not to some of you. I know good and well I'm not making a lick of sense to some of you. And that doesn't matter. But I'm going to tell it any damn way. Because you can then say what? That the difference between the potential energy and the kinetic energy at all times has to be zero. The difference between them. Because if this is max and the other one is zero, you get right off the floor about a millimeter from the floor, then the other one becomes max and the other one becomes zero. So as it does this number, they have to be what? The difference between the two of them has to be what? MGH minus 1/2 has to be zero at all times. If that is the case, then I want you to solve this equation for V that says MGH equals to what? That. Do you see that? Yes or no? So to solve this for V, I have this. I multiply this side by 2, I get this. Do you see this problem now? What are you going to do next? You're going to divide by what? By M on both sides. So when you divide by the mass, look what happens on both sides of the equation. The mass disappears. So the mass has nothing to do with its velocity hitting the ground. Do you see that? So if you solve this equation, it becomes what? Don't you see why they don't want you throwing things off the Empire State Building? This velocity would be what? Do that arithmetic. Tell me how fast it's traveling.
Almost 83,000 feet per second.
How much?
83,000 feet per second. 89.
No.
Oh, yeah.
Oh.
Yeah, that's.
You better fix that right.
288.
Yeah.
How much?
288. 288 feet per second. 288 feet per second.
How many miles per hour is that?
Give me 1 second, I'll figure it out.
Okay. You heard what I said. Go ahead, hurry. How many miles per hour is that rock traveling? Look, folks, why are you having trouble with this? You're having trouble with this because you were taught the wrong way to write fractions. You were taught to write a fraction like this. When I become dictator and when teachers start teaching kids to do fractions like this, they'll go to jail. That is not the way you write a fraction, ever. It is what? It is 288 feet per what?
1 second.
Per second. It's a simple problem now, folks, because now you want to change this to miles per hour, not feet per second. And this 288 feet is that portion of a mile. So now you got this is what? Miles. A second is what?
3600.
And your answer now falls out to be arithmetic only. Just plain arithmetic. Dividing complex fractions. That's what makes them complex. It's a fraction divided by a fraction. Y'all know how to divide fractions? Yes or no?
Yeah.
How?
You,
How do you divide fractions? How do you divide fractions? Somebody tell me.
Multiply.
What? So, hurry.
Multiply the reciprocals.
Invert and multiply.
Yes.
What?
Invert and multiply.
Yeah.
We divide and don't, that's why.
So, you said that. You said that.
She does.
I want to know why.
Because when dividing.
Why?
That's why.
Hell, I know the rules. I want to know why.
Says don't ask why.
I want to know why. How many of you know why you invert and multiply? Tell me.
I'm not sure.
Why? But hell, because you've been told so and you memorized it.
Because that's how many.
How many of you know why you invert and multiply when you're dividing fractions?
It's a rule.
I can't explain it without saying it doesn't equal 1.
Don't say a rule. Hell, I don't know who made that rule up and says what. Why? Why do you do that is what I want to know.
I don't know, I just learned the song. When dividing, don't ask why.
See, that's the problem. You need.
Because the opposite of dividing
No,
is multiplication.
that's not it.
Because you wanna.
I'll give you an example, and I'll use a student that happened about 25 years ago, right at this school.
Could you multiply?
I was walking in front of the library,
Opposite numerator?
and at that time, our library for this school was half the bookstore is now. The bookstore is double the size of the library. They knocked out the wall and made a bookstore.
It's the same thing as
But that used to be our library for the school, where the bookstore is located now. I'm walking along there, and this young student who'd had trouble with his math from the get-go came out of an English class, and he was just excited as could be. And he said he came running over to me, and he said, "Mr. Smith, did you know this? Did you know that when you divide something by 2, you multiply it by 1/2? It's the same deal. Multiplying by 1/2 is the same thing as dividing by 2. I said, yes, I knew that. But what do you suppose he had learned in the English class? He learned for the first time in his life how fractions behaved. Because what if he'd have said it the other way around? What if he'd have said, this is what he really said. He said, Mr. Smith, did you realize that dividing a number by 2 is exactly the same thing as multiplying it by 1/2? Now do you see why you invert and multiply? Because it's what? It's the same thing. That's why you do it. Not because you were told to do it. It's because it's the same thing. It's what now? First time you've been told that?
No, that's not.
You already knew it, right? I mean, you knew that already. But that young boy didn't. He did not. That's for the first time in his life he understood why and how you divided fractions. Because fractions used to give him fits. And it still does. It still does. I'll prove that next class. I won't wait till next class. I'll just write it right off this piece of paper. Divide that. I got time, I'll wait. I'm coming around to check work. You all should be through by now.
Should. That's not the rule.
You through? Got it?
I got a problem.
Why did you write it sideways?
Cause I want to write like that.
Listen,
It's just
folks, please. Y'all look, keep, you know what y'all learned in kindergarten, right? Stay in the lines. Stay in the lines. Look at her, she wrote this thing sideways.
But if I get the right answer, it doesn't.
Then you ain't gonna get the right answer writing it sideways.
Show not.
About 90% of the time you're gonna miss
Don't
it.
tell me how to.
I don't got the answer yet. I've shown you how to do it the right way.
Yeah, good God, I can't believe what I'm seeing. Oh, gee.
Numbers.
It's bound
I
to.
write scratch like that all the time.
Hell, I ain't putting no numbers anywhere.
I like the numbers.
Somebody else's problem. I want you to do that work. What you got? What you got?
That's not a very good. You're an idiot, Eric.
I don't know the right answer. I don't have the answer, y'all.
What?
Let's see. I don't know. There's an answer. Let's see what you got.
You do it wrong with that calculator. I get to pop your neck.
What the? Where the hell did you get that at? That's crazy.
Pop your neck.
Where's yours? Like that. Look at there. One up piece of paper. Wrong answer. Wrong answer. You all told me you knew how to do fractions.
Not without numbers.
No, you don't know how to do fractions. Look at this man. Oh my God, I can't. Gee, don't burn that.
I know, I talked to you. You didn't even see my-
Oh.
I got the answer. That's it, right there, it's X.
You don't even have paper. That's an answer.
I know yours is wrong.
Anybody got it?
I just, the back of your neck is wrong.
You hit me, I hit you back.
I can fight. You never did the last semester.
Nobody?
I'm doing it.
Over my leg.
How many of you don't know how to start this problem? God.
Put 'em high, put 'em
Oh, you do too. Yes, you do.
He does already.
How many other hands went up?
That one, that one, that one.
I mean, I'll do this the long, drawn out way for y'all, okay? Is that all right? We'll do it the long, drawn out way where you can follow step by step by step by step. So the first one says we have to do this. Let's do the top one first, okay? Is that fair enough? The common denominator is going to be this clearly, right? So the top one becomes this, and this divides this y times, this is y. Now this is y plus 1 over what? xy. Everybody okay? So that's the top. That's the top one, right? What is the bottom one? The bottom one is nothing more than what? Well, let's do this, okay? You have 1 over x, and the common denominator is going to be x. This is what? That's the bottom one, right? Say yes.
Yes.
Sure.
So now it's this is the, I'm erasing this away, I don't need this anymore. This now says what? Y plus 1 divided by xy, and I can invert that one and multiply. This is supposed to be what? This is supposed to be 1. No, everybody see that? This should be y, rather. That's y. That is the answer. Everybody okay?
Yes, we're good.
Any questions about that? No questions? So you have to be concerned about what? Working problems like this. Good example. Your average velocity for a trip that you go on. And you go on this trip in three separate ways, okay? The first set of the trip, you average 50 miles an hour. The second portion of the trip, you average 50 miles, what did I say, 50 or 40? Maybe you average 40 miles an hour. And the third portion of the trip, you average 70 miles an hour. So you got this, looks like this. And they give you an equation down at the bottom here that tells you that this is the equation looks like this, and you got to know what the equation. Y'all do that. Find out what this is without doing the arithmetic. You can do the arithmetic when you finish if you like. But the trip was V1 was 50, V2 I think was 40, V3 was what, 70. I not only want the answer in the number, but I also want the equation written out. Fair enough?
Yes.
Okay. Y'all have that to work on. See y'all back here on Tuesday? Tuesday? Continue to work on your